Welcome back, chemistry fans. Today, what we are going to do is our homework unit 1, topic number 6. And this is dealing with our electron configuration kind of pulled together with the orbital notation. So let me share my screen and we will get started on this topic really quickly here. Okay, so we're looking at chromium and we want to try and fill in the orbitals for this with the correct number of electrons. If you look on your periodic table, chromium is element number 24. You always start at the bottom where the lowest energy levels are, the closest to the nucleus. And what we would do is we would do up and down arrows, representing each one of those arrows would represent one electron. If we have them paired, they would be coupled like this, one going up, one going down, or you could do full arrows one way going up or the half arrows. I'm just making it quick and I'm going to represent it with an X. So here's 1, 2, 3, 4, 5, 6, 7. Notice that I filled them in partially first in an entire sublevel, and that gets us through Hund's rule. And then we will go 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, again, adhering to Hund's rule. Not only am I also adhering to Pauli's principle, which says maximum of 2 per orbital. And then 4s is number 20, 8, 19, and 20. And then we go to the Ds. And we got to go to 24. So we got 1, 2, 3, 4. Now, the reality is chromium probably is going to want a full sublevel or a half-filled sublevel in both of these. So it's probably going to do something like this. However, if you chose to just fill it straightforward and fill this one and then leave this one partially filled, that's also correct. But the reality is, if there's an opportunity for an element to borrow from an S to get a half-filled or completely filled, it will do that. All right. Moving on to number 2, it's asking us to define Hund's rule. I tried to do that in the context of the problem that we just worked here. Hund's rule says that you must half fill each orbital of a sublevel before pairing up. Now, it says that you also have to include energy level. Each orbital of an energy levels, maybe that's how we can do that. Half fill each orbital of an energy sublevel before pairing up inside that same orbital. In other words, what we need to do is make sure that we put one arrow in each box of a sublevel before you're allowed to pair it up, before you're allowed to move on to the next energy level. All right, or sublevel. Pauli's principle just simply states that you can have a maximum of 2 electrons in a box. You can have 0, you don't have anything in there, you can leave it blank, you can have 1, or you can have 2. That's what Pauli's principle says. You cannot ever have 3. It is not possible. Draw an image now of where electrons are located. I didn't tell you the element, so let's do that. Let's change the homework assignment. It's now going to be for, let's do it for nitrogen, okay? So what we're going to do is we're going to put 2 electrons in the first energy level, and the S sublevel is spherical in nature. And then we're going to put 2 more, so now we're up to 4. Coming out of this, however, we're going to have the opportunity for these 6 orbitals. Inside of those 6 orbitals, we're going to need to put 3 electrons. So we can put 1, 2, and 3 inside here. This represents where the electrons go for a given element's electrons in their sublevels and in their particular orbits. So that's what we want from you. Thank you very much for your time. Talk to you again soon. Bye-bye.